Hello, everyone, and welcome to Precalculus. This is section 10.2 on parabolas. It's also the first lesson on something that we're going to call conics. So a conic section is the intersection of a plane and a double-napped cone. All that means is that you have a cone on top of another cone. So they come together kind of like an hourglass would. And if you take a plane, you can intersect that cone in different ways. So if you intersect just that one cone and you don't actually hit both of them, then it forms a parabola. If you take your plane and you slice straight across one of the cones, that's how you get a circle. But if your plane is slightly tilted, it's going to form an ellipse. And if your plane goes through both of the cones, then it's going to make something called a hyperbola. So over the next 4 days, next 4 lessons, we're going to study these 4 different kinds of conic sections. So there are going to be 3 ways that we could study conics. Geometrically, we just described it. It's the intersection of planes and cones. Now, of course, we have studied some of these things algebraically. They form some kind of a second-degree equation. The third way is really interesting. It's as a locus or a collection of points that satisfy a geometric property. So for example, you could think of a circle as having a single point, and if you drew every single point that was exactly the same distance from that initial point A, you would create a circle. This is the collection of points that are all a certain distance away from A. So that's how we're going to study parabolas today. We've already studied parabolas algebraically. F of x is equal to ax squared plus bx plus c. This is something you're really familiar with. We're going to do it as a locus of points. And the reason for that is because it'll allow us to find interesting parts of the parabola. So this is a slightly confusing diagram because you're not used to it. So I'm going to try and put it in terms that I think you'll understand. Let's say that we were in class and this is the wall. And then let's say I picked a student, let's say Abby, and I told the rest of the class they needed to find a place to stand where they were the same distance from Abby that they were from the wall. So, of course, the first kid that stands up is going to be like, that's easy. Kid letter A. Do they need names? Sam. Sam stands here. He figures he can walk to Abby or he can walk to the wall in the same number of paces. But now, where is Tom going to stand? Where is he going to stand that he isn't standing on top of Sam, but he's also the same distance from Abby as he is to the wall? Well, he could stand here. Then, if he walked to Abby, or if he walked to the wall, he would be the same distance away. What about Luke? Luke says, I think I can stand way over here. It'll be harder to walk to Abby, but it's still the same distance as walking to the wall. And what about Mary? Mary might say, well, I'm going to stand really close to Sam, but I do have to pivot just a little bit. So she's that distance to Abby and that exact same distance to the wall. Mary stands there. And then maybe Sue stands right here. Oh, pen's not doing good there. All right. So let's say Sue stands here. Okay. So if everybody in the class, if you had 20 people in the class and they kept standing, they would eventually form a parabola. Now, obviously, my parabola is not perfect, but that's the collection of points. So they are formed by the intersection of a cone and a plane. So if you just go like this with your plane, your slice of paper, it's going to make a parabola. And of course, we've already studied parabolas in this form, but now we're going to talk about it this way. So a parabola is the set of all points. So Luke is a point, x, y, in a plane that are equidistant from a fixed line. So this wall is called the directrix. The wall is the directrix. So they're equidistant from a fixed line and a fixed point. So Abby is the focus point. So everybody's focusing on Abby and the wall, and these are their actual names, focus and directrix. And the parabola is just all the points that are equidistant between the two. So how do we translate these into problems? All right, don't be scared. There's 4 different formulas, but they're almost identical. It's just they put them into 4 different categories based on whether or not it was going up, down, right, or left. So every time you do a problem, you're going to want to look at these. So make sure that they are in your appendix. All right. So first step in solving these, let's just get right down to a problem. Find the vertex, focus, and directrix of this parabola. So I look up here at my chart and I see that it is a square. Both of these are. So I need to figure out what P is before I know which one it is. So this little piece right here in front of the x minus whatever, okay, that is 4P. So your first step is going to be to find P. P doesn't really mean anything to you, but it's actually going to have a lot of importance. So P is equal to 2. So step 1, find P. Right? Now that we've found P, we know which of our equations it matches. It's going to match this one because P is less than 0. So now I know that I'm looking at a sideways parabola that's opening to the left. So second, I can plot my vertex. So the vertex is going to be right here and here, but you have to be careful that on the y ones, this is going to be backwards. So it's actually going to go 4, 2. And luckily, just like everything else we've learned in math, these are the opposite because they're inside the parentheses. So 4, 1, 2, 3, 4, and then 2. And then here's how P is used. P is the distance between the focus and the directrix. So it's going to go back 2. So this must be the directrix. It's also the distance to the focus. So now I know that this is my focus point. And I also know that my parabola is going to do something like that. But of course, we need to find one good point on it. So we'll do that in a minute. So I can plot the vertex, 4, 2. And then step 3, use P to find the directrix, which for ours is a vertical line, which means it's x is equal to. Remember that sometimes the directrix is going to be horizontal and then it's going to be y is equal to. X is equal to -6. And use P to find the focus, which for us is going to be 2, 2. Then it said sketch its graph. So I do want you to find one good point, which actually finds you 2 because of symmetry. This is a little bit challenging because it's not in the form y is equal to, so we can't just pick any x. So the way I do it is I kind of think about, well, I need to make this side a perfect square because I'm going to square something that has to make this side. So how can I make this side a perfect square? I can make this side a perfect square if I can make it into 1. I don't want to make it into 1 because that would mean this was 1/8. I could make it into 4. which again, 8 times what would make 4? Half. I don't want to do that. I could make it into 9. Okay, that's really out of the question. 16. Oh, this is promising. So I have negative 8 times x minus 4. Could I make that into 16? Definitely. If this was negative 8 times negative 2, how could I make this into negative 2 if x is 2? And there are definitely people in the room going, I'm never going to get that. No. You can get it because there's only so many perfect squares and the problems are kind of contrived, so you'll get it. And now, knowing that this is a 2, this side is 16, so I have y minus 2 squared is equal to 16. So square root both sides, y minus 2 is equal to plus or minus 4. Y is equal to, if I add 2, I get 6 if I'm using positive 4, or negative 2 if I'm using the negative 4. So at x is equal to 2, I get 6 and negative 2. So at 2, I get 6 and negative 2. And now I can draw a really good parabola. And you may be thinking, so why did we find the directrix and why did we find the focus if they weren't even part of our sketch? They have other purposes. The focus is actually going to be huge in word problems. The focus is the thing that they use to decide where they're going to put that antenna. So when your radio waves and your cable waves come in off a dish, I'm sure you've all seen the satellite dishes, they come in and then they all go to that focus point, that antenna. So no matter where the waves come in, they all will go to that, which is fascinating. Or maybe there's a boiler, maybe there's a giant parabola, and right here there's a boiler. And so they fill it with water and they want it to heat, but they want it to use the sun. The sun ray comes in, and if they've made the parabola the right shape and the boiler at the right height for this focus, then that all those sun rays will come in and hit it. So it actually has really cool applications. But it's not part of our graph, so you still have to plot good points. All right, if you're feeling a little overwhelmed, don't worry, we have lots of examples that we can still do. So find the equation of a parabola with the vertex at the origin and the focus to 0. The key is to make a sketch. I feel so strongly about this that I'm going to also put a warning on here. There is no partial credit without the sketch. Meaning, if you get an answer, even if it's only off by a tiny little bit, but you haven't bothered to make the sketch, I'm not giving you partial credit for it, because it only takes a second to make the sketch and know which of these 4 equations you want. So if the origin is 0, 0, that's where the vertex is 0, 0, and the focus is at 2, 0, the focus is always inside. Remember, think boiler and parabola. So that means it must be going like that. That's all I'm looking for from your sketch. I just want to know that you've figured out which one it is. Now look at your chart. This parabola has the equation y minus k squared is equal to 4p times x minus h. So step 1, make the sketch. Step 2, pick the equation and write it. Don't try and fill it in right away. Write it. That way, again, if you're looking for partial credit, I can say, well, they picked the right formula. And then step 3, fill it in. Remember that h comma k is your vertex. So ours is 0, 0. And then p is this distance right here. If you knew the directrix, you could use that distance. So in this case, this parabola opens to the right, so p is considered a positive number. So it is 4 times 2. And then step 4, you should simplify, which gives me y is equal to 8 times x. That's it. Let's do another one just like that. Or if you want, you can pause this video and see if you can do the next one on your own. Find the standard form of the equation with vertex at 2, 1. So step 1, make a sketch. The vertex is right there. And the focus is at 2, 4. So 1, 2, 3, 4. Again, the focus is always inside the parabola. So my parabola must look like that. Now that I can see that it's an upward parabola, I pick equation, I don't know if you want to label them A, just because I don't want to keep going back to this page, but if you label them A, B, C, D, you'll know what I'm referring to. So I'm going to pick A because that one goes up. So equation A says x minus h squared is equal to 4p times y minus k. So step 3, I'm going to fill it in. My vertex is 2, 1. Remember, the x coordinate always goes with the x. It's not in the order that they appear. So x minus 2 squared is equal to y minus 1. And p is the distance from the vertex to the focus, which in this case is 3. And because it's an upward parabola, it's a positive 3. And you are not required to simplify this any more than this. This is considered the standard form of this equation. X minus 2, the quantity squared, is equal to 12 minus y. Number 4, find the vertex, focus, and directrix. So we're going to go backwards again. Now, this format doesn't match any of the equations that were given to you, not A, B, C, or D, but you can see that the y is being squared. So all of the equations have the square term all by itself on one side and everything else on the other. Now, I know this might look a little silly that they've put x plus 3 in parentheses, but they were just trying to help you out. You should leave it together. Leave it this way, because while it's together in parentheses, this represents the h. So you really want it to look like that. If you distribute it to this, then your formula doesn't work anymore. So you actually need it in that form. So they were being nice. So my vertex is negative 3. Remember to do the opposite. Positive 1, negative 3, positive 1. That is my vertex. And then what is P? So remember, this number right here, which is a 1, is always equal to 4 times P. It was a little easier doing it in the other direction, where we just found P and then put it in. But see how this number, you're always going to set this number equal to 4P to find P. P is 3. So, but now we're doing it backwards. This time, 4P is negative 1. So P is negative 1/4. That means that I have to go 1/4 in a certain direction in order to get the focus in the directrix. So you need to know which one this matches. Since y is being squared, it's either going to be C or D, and since P is negative, it's going to be equation D. So if you're looking back on your chart, it's the 4th one, equation D, which means it's going to go backwards like that. So if it goes backwards like that, then my focus is right there. What is that point? That point is at the same height. It's still at 1, but instead of being at negative 3, it's another quarter away. So negative 3 1/4. And my directrix goes a quarter in this direction. Remember that all vertical lines are x is equal to. And where is it? Well, it's not quite at 3. It's been moved back a quarter. So it's at 2 3/4. This is your directrix. So I did it. I found the vertex and the focus and the directrix. And now I just have to sketch its graph. So here I go again. This is, in my opinion, the hardest part. Making a table and finding one good point. You have to find a point that is going to make a perfect square. So I think to myself, now you might want to distribute it. Negative x minus 3. You need this to come out to be a perfect square. So right away, a perfect square has to be positive. Well, for this to be positive, x has to be bigger than 3, and x has to be negative. So if I make it negative 7, does that work? It sure does. Negative 7 is positive 7, and 7 minus 3 is 4. So that's one possibility. And then on the other side, I would get y minus 1 squared is equal to this thing that I just figured out, 4. So I square root both sides. I get y minus 1 is equal to plus or minus 2. And then I add 1, and I either get 3 or negative 1. Darn, how am I going to do that, right? Because negative 7 isn't quite on my graph. So you need to find another one. Another choice would be negative 4. People forget about 1 being a perfect square, but that one also works. So negative 4 plus 3 is just, it's a minus 3. Positive 4 minus 3 is 1. So like I said, don't forget that people jump to 4 in bigger numbers, but if you can make it equal to 1, that's usually going to be your best bet. So when I square root both sides, I get plus or minus 1. So when I add 1, I either get 2 or 0. So negative 4 is going to make 2, and negative 4 is going to make 0. This one made 7, made 3, and negative 1. All right, but negative 4, 1, 2, 3, 4, and 2, that looks right. And negative 4, 0. So it looks like this. Okay, I realize that that is a little bit tricky to do, but it's actually good that you get this ability to play around with numbers. Number 5, find the standard form of the equation of the parabola with directrix x is equal to negative 3 and a vertex at the origin. So remember, step 1, make the graph. So don't forget, every time you have x is equal to a number, it makes a vertical line. And if you have y is equal to a number, it makes a horizontal line. So ours is x is equal to negative 3, so our directrix is right there. The vertex is at the origin, and a parabola always faces away from it. This one doesn't say make the sketch. So you're just doing that for you. These points do not need to be nice. You're just making that real quick for you. But what I learned from this is which direction it's in. So now I look back at my chart, and this is, if you labeled them A, B, C, it's C, or the third one, which means my second step is to copy down the equation. Don't try and fill it in right away. Take 10 seconds of your life and copy it down. Then fill it in. So remember that HK is the vertex, which in our case is 0, 0. Love when that happens. And then P is the distance to the directrix. So in our case, P is equal to 3. So whether or not P is positive or negative will depend on which way it's going. So it's pretty easy to remember. Up is positive, down is negative. And then when it's going left or right, this parabola is considered positive and this parabola is considered negative. So our P is going to be considered positive, so 3. And I get y squared is equal to 12x. Number 6, find the standard form of the equation of the parabola with vertex negative 2, 1, and directrix x is equal to negative 1. Again, that's a vertical line at negative 1. And since the parabola always goes away from the directrix, again, if you're ever having trouble, just try and imagine a person standing here. For them to walk to the wall or for them to walk to the vertex should be the same. So now that I see this picture, I look over at my graphs and it's equation D, or the fourth one, which is y minus k squared is equal to 4p times x minus h. My vertex is negative 2, 1. So I'm going to fill that in. Make sure you don't put the negative 2 here. It's easy to do because you're used to going from left to right, but the x has to go with the x. It becomes a plus 2, and this is a minus 1. P is the distance between the vertex and the directrix, or if they'd given us the focus, it would be there. So 4 times 1. But be careful, because this one is going in the opposite direction, P is negative in this situation. And you don't have to simplify that other than just changing that to a negative 4. In fact, it's probably better that you don't multiply that out, because this is more informative than negative 4x minus 8. It didn't ask you to make a sketch, so just that little rough sketch that I did is really good. So remember, y squareds are going to go left and right, which is also easy to remember because we've been doing x squared all year, and you've always made parabolas up and down. So when you see a y squared, that's another way to know that it's going to go left or right if you don't want to keep using your chart, or if you're in honors and you're not allowed to use your chart. Find the focus, directrix, and vertex of the parabola x squared minus 2x plus 8y plus 9. All right, you guys ready? This is where it gets hard. This is nothing like what we need. So we are going to take everything that's with x's and put it on one side, and everything that's y and put it on the other side. And I'm going to leave a little gap because we're going to complete the square. We did this earlier in the year, but during the next 3 sections of conics, completing the square is going to be really important. So to complete the square, there's a really nice pattern to it. You just take half of this number, which is minus 1, and the number you just got, you square it and complete the square with it. X squared minus 2x plus 1 is the same as x minus 1 squared. But you can't just add a 1 to this side of the equation. So we're also going to add a 1 to this side of the equation. And then this side comes out to negative 8y minus 8. Now, just like before, I said I actually didn't want you to multiply this out to this. This is not as useful. If you want to know P, you need it factored out. If you want to know H, you need to have it factored out. So that's what we're going to do. We're going to factor out that negative 8. Pretty much whatever's in front of the y, you're going to factor out, because this, in order for this to work, it has to just be y plus or minus a number. So I factored it out. I know I've told you this all year. Factoring is not going away. So now that I have my equation, I can find the vertex, which is hk, so positive 1, negative 1. And then the focus. Now, there is a little chart that will tell you how to find the focus and the directrix underneath here. Like, it'll give you all the little pieces of that. You can do that if you want to. I have never done that, especially if you're in honors and you're not going to have that chart in front of you. It's very easy to do this if you just make a sketch. So since it's an x squared, I know it's going up or down. And since it's negative, I know it's going down. So I just plot my vertex, 1, negative 1, and then I just draw a little picture of it going down. I find 4p. So negative 8 is equal to 4p. P is equal to negative 2. And then I try and picture it. If here's my vertex, then the directrix must be up 2. It's right there. So my directrix is the line. I don't know why I put parentheses. Sorry. My directrix is the line y is equal to 1. And my focus is inside the parabola, and it's also 2 away. So what is that point visually? It's just 1, negative 3. I personally think that is way easier than using all those complicated things that are on that picture. Just draw it. And that's how you do number 7. Definitely this completing the square thing is a little tricky. So we're going to do another one. All right. So I see that there's the y is squared this time. So everything with a y, I'm going to put over here on this side. That's the only thing. So everything that doesn't have a y, I'm going to put on the other side, which would be 4x plus 4. Now, don't get confused. If there's no other y, you don't have to complete the square. It means it must just be 0. Be happy. Okay? But you do still need to factor this side. You always want it to be in this format. So my vertex is going to be -1. Really easy to put these in the wrong order because you read from left to right, but x first, then y. And then, you know what I'm going to say, don't you? 4p is equal to 4, p is equal to 1. Make a sketch to get the rest of it. So -1, 0 is my vertex, and since p is 1, and since I know it's a sideways parabola, whenever I see a y squared, I know it's one of these two, and since p is positive, I know it's this one. So I have my vertex, I know it goes this way, and now I know that my p is 1, so that means my directrix, the directrix is not going through the parabola, it's always on the other side of it. My directrix is a vertical line, so it's x is equal to -2. And my focus has to be 1 in the other direction, p is 1, and my focus is 0, 0. What else do they ask? Oh, how would you graph this function on your graphing calculator? So that's a great question. If you look at your graphing calculator, which you've been doing all year, I'm sure you realize it says y is equal to, y2 is equal to, that, but there's nothing in there about y squared. You can't touch that side of the equation. So unfortunately, the only way for you to graph this would be for you to take the square root of both sides. So you'd have to do the square root of 4x plus 4. But remember that whenever you take the square root of something, you get plus or minus. So instead of putting them both on the same one, you actually would have to do two separate functions. And that would give you your y1 and your y2. That's how you would do it on your calculator. Number 9, another chance to complete the square. I realize that these are super hard. You can do it. All right. So for me, I see, first I'm just going to clear the fraction. You've been hearing me say that all year. So I multiply by -2 because I want to get rid of that negative also. And then I get -2y is equal to x squared plus 2x minus 1. Whew. Honestly, it is already an easier problem. So this one's clearly going to be an x squared, but I personally leave all the things together, and the thing that's not squared, because this is the side I'm going to have to work hard at completing the square on, I put everything else on the other side. So -2y plus 1. I'd move that y. That way I can just focus on completing this square. So again, how do we do it? You always take this number and cut it in half, and then the number you just got, you square it and put it right here to complete your square. X squared plus 2x plus 1 is x plus 1 squared. But since I added a 1 to this side, I do need to add a 1 to this side to keep it the same. And look at this. Now you can factor. These problems are very contrived. Just enjoy that. If you take higher level math, I assure you they will make the problems harder. But at least you can enjoy it for right now. If this is freaking you out that it's not exactly how the formula looks, you can switch the two sides. That's fine. All right, what did the question even ask? Find the focus. So I really can't find the focus without doing everything else. So for me, I say this is an up or down parabola because it's x squared. And since it's a -2, it's the down one. And my vertex is at negative 1, 1. So negative 1, 1. And my P, well, my 4P is negative 2. So my P must be negative 2/4, which is negative 1/2. So I'm doing a downward parabola, and my focus is negative 1/2. So it's down a half from there. So what is that point? Well, its x coordinate didn't change, so it's still at negative 1, but instead of being up here at 1, it's down to a half. This is my focus. But notice that even though this time I didn't ask for vertex, P, directrix, everything else, I just asked for the focus. It doesn't mean you can suddenly skip all those steps. Those steps are really important. Number 10. So I put number 10 on here because some people are really confused about how to clear fractions on this one. So think about this. If you had 4 times 5 times 2, you would do 4 times 5 probably is 20 times 2 is 40. Or maybe you would see the 5 times 2 first, and you would do 5 times 2 is 10 and then times 4. But either way, when you have 3 things being multiplied, you know that you have to kind of think about 2 of them together and then do the third one. That's how this works. I'm going to multiply this by negative 6. And some people accidentally clear the fraction, but then they still distribute this 6 to the other one. That would be like doing 2 times 4 and 2 times 5, which would be wrong. So it's really important that you realize if you multiply both sides by negative 6, you will clear this fraction, and then this is just x squared plus 4x minus 2. And like I keep saying, doesn't it already look better? Just getting rid of the fraction is better. I personally always complete my square without anything else going on, so I'm going to move that 2 to the other side. That way I can focus on completing the square. You always cut this number in half, and then you take the number you have and you square it and add it to that side. Since you did that, you have to add it to this side as well. X squared plus 4x plus 4 is the same as x plus 2, the quantity squared. And on this side, of course, my beautiful, contrived textbook problem. They made it so you could factor it nicely. And I'll make it so you can factor it nicely on your quizzes and your tests. X plus 2 squared, just to make it look like it does on your formula sheet. This is my final problem. But again, they asked me to find the focus. I have to do the whole thing out. I have to say it's an x squared and it's facing down. So I make a super quick sketch. My vertex is -2, +1, -2, +1. My focus is going to be somewhere below, but how much below? You're going to have to do P. So this one is a little harder. 4P is -6, even though these problems are contrived. The P is not always going to be a nice, easy number. So it's -6 over 4, which is -3/2, or if it's easier for you, 1.5. So from this point, which is up 1, I'm going to go down 1.5. So right there. So I'm going to be at -2, -1/2. That's going to be my focus point. This is, by the way, the hardest of the 3. So we'll do parabolas, ellipses, hyperbolas. If you can get through parabolas, you're set. This is by far the hardest one. Ellipses and hyperbolas are a piece of cake. All right, we're going to close on a word problem. Sunfire is a glass parabola used to collect solar energy, like we were talking about before. The sun's rays are reflected from the mirrors toward 2 boilers located at the focus of the parabola. When heated, the boilers produce steam that powers an alternator to produce electricity. This is real world, guys. This is cool. Given that the boiler is 10 feet above the vertex of the dish, write an equation for the Sunfire's cross-section. So a cross-section is like if you were going to slice something. So it means like you want to see a flat two-dimensional picture of something that's actually three-dimensional, which of course is what we've been doing all the time because we're drawing them on a piece of paper. So even though this is a giant dish, we're just going to look at the cross-section of it. And it is an upward parabola. We assume it's upward because it's trying to catch the sun. So it's going to be x minus h squared is equal to 4p times y minus k. And you might as well, there's nothing saying where it is, so you might as well just put it at 0, 0. And what is my p? The distance to the boiler, which they said was 10. So the equation is x squared is equal to 40y. All right, you did it. That was Parabolas, section 10.2. Have a great day.